Okay, so in this first example, we're going to talk about Charles' law, which is the volume and temperature relationship rule. Now, again, you don't need to know laws' names. You just need to know what the relationship it is between volume and temperature. So again, volume and temperature, as we saw in the animation, are directly proportional, meaning that as the volume goes up, the temperature will go up. So let's set up the problem. Now, this problem has something slightly different than what we saw previously in the pressure versus volume situations. And so let's jump into it. Now, because this is a direct relationship, it's going to have a slightly different formula than we saw with the pressure versus volume. So remember the pressure versus volume, which are opposites. The ones and the twos on the left and the ones and the twos on the right were opposite to each other. So the P1 was on the top left and the V1 was on the bottom right. Now, because it's direct, they change in the same direction. So we have V1 divided by V2 is equal to T1 divided by T2. So as you'll see in all the animations, the only one that's different is pressure versus volume. So you just have to keep that in mind when you set up all your problems. Now, just like we did previously, you want to write down what you know. So I know that temperature 1 is 20 degrees Celsius. How do I know that? Because it's the first temperature that's given right here. Okay, it's 20 degrees Celsius, but something very specific has to happen here. And this is where I'm going to get into it. You have to add another factor. See, we don't work in Celsius when it comes to gas laws. We work in something called Kelvin. Kelvin is a unit of temperature, like Fahrenheit is, but it's got a different factor. See, the thing about Kelvin is it's an absolute, meaning there is no negative numbers. The lowest you can have is 0. So what that will mean is when we do these calculations, you will always need to convert to kelvins before doing any of the math. Okay? You'll get a radically different answer if you don't do that. Okay, so keep that in mind. It just popped on the screen. Remember, anything in those blue bubbles are always, make sure you write those down. So how do I do this? Well, Kelvin is whatever the degrees Celsius is plus 273. So you've got the 273 right there. So I'm going to take 20 plus 273, and that's 293 Kelvin. My T2 is the second temperature that's given. So that's going to be 40 degrees Celsius plus 273, and that's 313 Kelvin. Okay? So while it looks like it doubled the temperature, it didn't actually double the temperature. It doubled the Celsius temperature, not the Kelvin temperature. Now my volume is just 1. How do I know that? It is right here. Okay? So my volume is the only one given. So again, like in pressure versus volume, you know, the things that are connected to each other go together. So my V1 is 1 liter, my T1 is 20 degrees Celsius, which is 293. Okay, my V2 is what I'm solving for. How do I know that? It says, what is the volume? So I'm solving for volume. So I plug my T2 in, and I plug in a V2. Now, like a proportion, we're going to cross multiply. So I'm going to multiply the bottom left by the top right, and the top left by the bottom right. Okay, so let me get my calculator out. So I'm going to take my bottom right and multiply by my top left. So 313 times 1. Obviously, that's 313. And then I'm going to divide by the thing that multiplied by the variable. Okay, divided by 293. And I get 1.07. Remember, we're going to round so that we're going to round to 3 places, but we're going to start counting with the first non-zero. So the 1, the 0, and the 6. The 6 would round up because there's an 8 after it. And so my final answer will be 1.07 liters. Okay, and what I always like to do is, we got a lot of numbers on this page now. It's not like in previous problems where everything was nice and simple with simple calculations. Got things going all over the place. We have a conversion to temperature. We have volumes. So I always like to box my answers when I get to the end. Okay? And that's how you solve a volume and temperature relationship. So keep in mind when you do this, number 1, volume and temperature are directly proportional. And number 2, before you do a calculation with any temperatures, you always convert to kelvins first.